back everyone. This is the second tutorial of a series introduction to Aspen High Seas. If you are new to High Seas, I would strongly recommend you please go through the first tutorial of this series. The link is available in the description of this video. In this tutorial, we will learn how to calculate bubble point and dew point of a pure component as well as of mixture in high seas. So let's first recall some important definitions. What is bubble point? The bubble point is the point at which the first drop of a liquid mixture begins to vaporize. On the other hand, dew point is the point at which the first vapor of a gaseous mixture begins to condense. So let's compare bubble point and dew point of a pure component with mixtures. In case of pure components, bubble point and dew point are same. For example, if we have a water at 1 atmospheric pressure and we heat it up at 100 degrees C, all water will convert from liquid phase to the vapor phase. On a vice versa, at the same pressure, if you cool down the water vapors at 100 degrees C, all the vapors will convert into the liquid phase. So water has 100 degrees C as a boiling temperature as well as a dew point temperature. But this is not true for mixtures. Mixtures have different bubble point and dew point because they have different vapor phase and liquid phase composition at given temperature and pressure. When mixture starts to boil, the vapor phase will be rich in concentration of a component with low boiling temperatures. On the other hand, the liquid phase will be rich in concentration of components with high boiling temperature. These concepts further be explained via phase diagram. Now, let's practice these concepts in high seas. First, we will solve a problem to determine bubble point and dew point of a pure component. The problem statement is to calculate bubble point and dew point temperature of a hexane at 1 atmospheric pressure and 2 atmospheric pressure. Let's move to the high seas environment to solve this problem. Now we are in high seas environment. First thing is we have to define components. Just press this add button. Write the component name, that is hexane. Press enter. Now the component is selected. Next, go to the fluid packages. Because our system is purely hydrocarbon based, so we will choose Ping Robinson as our fluid package. So here, Ping Robinson. Now all the required information in the property environment is done. Let's move to the simulation environment. Okay, now we are in simulation environment. We have to specify a material stream. Just press this blue arrow and then press again in the flow sheet. Close this tab, double click and write the name of the stream. So we can write it like bubble point. Okay. So in problem statement, we only know the pressure. We have 1 atmosphere, we have to find bubble point temperature at 1 atmospheric pressure as well as at 2 atmospheric pressure. So first, let's determine at 1 atmospheric pressure, write 1. Now the units are in bar, but we have to specify the unit in atmospheric. So just press this small arrow and then from this dialog select ATM. Okay, for basis just take 1 kg or 1 kg per hour as a basis of this. So go through this tab. You can see it says unknown composition. Go to the composition tab. Here we have only hexane. Just edit. So mole fraction, just press 1 because only one component is here, and then press OK. So it says unknown temperature. Go to conditions. So here you can see either we have to specify temperature or vapor fraction. But for bubble point and dew point calculation, we must have to specify vapor fraction. For bubble point calculation, we have to set vapor fraction equal to 0. It means that this is a saturated liquid stream that is ready to boil, and the temperature that we obtain here, that is 69.01, is the bubble point temperature for hexane at 1 atmospheric pressure. Now if we have to find bubble point at 2 atmospheric pressure, what we will do, just press here, press 2 and 2 atm, and then automatically you can see at 2 atmospheric pressure the bubble point of hexane is 92.95. So if we want to know the dew point of the hexane, we will simply I want to change the name of this stream, say now dew point. Okay, for dew point we have to specify vapor fraction equal to 1. It means this is the stream that is a saturated vapor and ready to condense, and this temperature at 2 atmospheric pressure is the dew point of a hexane. So you can see the bubble point and dew point at a constant pressure is same for a pure component. Now let's solve a problem for mixtures. So the problem statement is a liquid mixture contains 60% pentane, 40% hexane in mole percent. So at 400 degree Kelvin, the pressure is gradually decreased. What will be the bubble pressure and the composition of first vapor that is formed? And also in second part, we have to find what would be the bubble point temperature at 10 bar pressure. So let's move to the HYSYS to solve this problem. Well, in HYSYS, first we have to specify the components. To specify component, just press this button and then write your desired components. In our case, it's pentane. Press enter, and then hexane, and then press enter. So we specify the components. Now let's move to the fluid package. Press again, our system has only hydrocarbons, so the fluid package, that is Pink Robinson, would be good for property estimation. Just press Pink Robinson, and now move to the simulation environment. Select the material stream, double click on this stream, change the stream name. So here we have to find bubble point. Just write bubble point, and then we have temperature is given, that is 400 Kelvin. Just press 400 Kelvin. Take basis 1 kilogram per hour of the mixture, and now it says unknown composition. Go to the composition tab and define the mole fraction that is given in the problem statement. Just press edit. For pentane we have 60%, so 0.6. For hexane 0.4, press enter, and now the composition is specified. Go to the conditions back. As I already discussed, if you want to know bubble point temperature or bubble point pressure, we must have to specify vapor fraction. For bubble point, we have to set vapor fraction equal to 0 to make this stream a saturated liquid. So now you can see the bubble point pressure for this mixture is 7.96 bar. And the second part of the problem was what would be the composition of first vapor. For that, just press here on a composition tab, and then you can see the vapor phase composition, the first vapor composition. Maybe you can see now better. Pentane have 0.7 mole fraction and hexane 0.26. Because hexane has higher boiling point, as expected, it is lower in vapor phase. Another interesting thing that you can do in HYSYS, you can create a phase diagram for this system. To create a phase diagram, just go to the left side of this simulation environment and press this stream analysis tab. Okay, and then add what we want. We want envelope, pressure volume envelope, and then select the stream name, bubble point, press OK, and now we have the pressure, volume, pressure, temperature calculation for that. So for this system, two-phase critical temperature is 213, two-phase critical pressure is 32 bar. So just go to the performance tab. So now you can see this is the phase diagram for this system. The red line is for a bubble point line, and blue line is a dew point line. Above this red line, the two phase stays in liquid phase, and below this blue line the vapor phase exists, and between these red and blue line two phase exist. And here at this point where dew point and bubble point curves are matching, this is the critical point for this system, critical temperature and critical pressure. Not only you can have pressure, temperature, phase envelope, but you can have temperature volume, pressure volume, temperature enthalpy, pressure enthalpy, temperature entropy, and pressure entropy. So from here you can generate all types of phase envelope for your desired system. That's all for this tutorial. I hope now you are able to calculate bubble point and dew point for a pure component as well as for mixtures, and I can anticipate now you are able to generate a phase diagram in HYSYS. If you like my video, please subscribe my channel and stay tuned for upcoming videos. Thank you. Bye bye.